SEPS Strategic Plan. Proofs of Concept. As part of the SEPS Strategic Plan, proofs of concept were developed to demonstrate workflows that will be possible if the strategic plan is implemented. The proofs of concept are not comprehensive and are intended to be demonstrations of some potential workflows and tools. The tools used were not selected as the only solutions possible, but to illustrate what type of an ecosystem could develop in the next version of SEPS once a services-oriented architecture is enabled. Some of the proofs of concept are fully functional or partially functional demonstrations. They are not intended as final working solutions. Other solutions and vendors are encouraged to demonstrate how their solutions fit into the SEPS ecosystem. The goal is to create a plug-and-play modular platform that will allow any number of current or future solutions to work with SEPS. Proof of concept number 4, templates and criteria management. This proof of concept is specifically about how criteria and templates can be managed and maintained. This is not for the SEPS end user, but for the criteria managers, the committee, and the stakeholders that are involved in updating information about criteria. It's about how to automate part of the process by making the SEPS data services-oriented and accessible on max.gov. It's restricted access to specific users based on the login that they have, and it covers the SEPS 3.2 and 3.9, the platform in the transition phase. In a similar way as the previous web services demonstration, the data is, the exact same data that is available on max.gov. The difference is that the access levels and who gets to view and edit it is different. So depending on how you log in, the authoritative source is the same, but in this case we're actually going into how data gets edited either by machine or by a person. The output could still be similar to the 1691 and the other standards that are used by designers and project managers, program managers. So if we take the SEPS data that exists in max.gov, there are also BIM objects from the templates developed by MHS for specific room types. And that's part of the discussion we want to have here. If there are over 800 room types and several thousand variations of rooms with equipment in it, if you had several thousand spaces in BIM, once they're all complete, how do you maintain them? Do you have to go into each room and maintain each object? The data, the source of the data, the authoritative source is coming from SEPS. So this proof of concept is all about how do we push that data out through the templates and how do we maintain it over time as the 1691 data that gets updated, for example, or as criteria changes. Edits that happen in the tables should trickle throughout the different templates into the different BIM applications. And this is kind of a snapshot of many different BIM applications, both on the web and on the desktop, using the SEPS criteria and template. So for example, if we have a template that is a typical exam room, like this one here, and next year a new piece of equipment, a new object needs to be added based on the criteria that's been updated, or maybe all the equipment gets changed or shifted, or half of it gets changed. You can automatically, through web services, actually do things like color code the piece of equipment that's new or that it was taken out, for example, or even add a new piece of equipment that doesn't even exist in higher levels of detail. In the MHS templates right now, all the objects are higher level of detail objects that have been developed. We've actually counted a couple of hundred unique objects that already exist in the 40 or so templates that are in BIM. For this proof of concept, we've extracted those objects and connected them to the JSN numbers from the 1691, and also demonstrated a live connection as new objects are added, how they can update these rooms and even the attributes associated with them. And the objects and data associated with them would be exactly the same whether they're on the web in a graphical interface like on the left, or in a desktop applications in a full BIM application, or even in a report. We can actually show how through publishing the data it can actually show up in a report. So let's move on to the next phase here. So for example, we have 808 rooms in SEPS, over 6,000 room types, unique room types, each with their own JSN equipment in it, millions of data points. So even in these room types with each object has attributes. So if you start multiplying all that together, it's literally millions of variations that if you add the need to maintain it over time, it becomes absolutely impossible to do it manually. Therefore, with SEPS, the next generation of SEPS, being web-enabled, being services-oriented, focused on data, it can start pushing this data into objects, into BIM, or into reports, and as changes are made, they make their way through the objects. So maintenance becomes an issue unless we can automate this with this proof of concept demonstration. So for example, there's a couple ways that a template gets edited. So when a criteria gets updated or new templates or departments are updated every several years, the room size might change, for example. The criteria, the stakeholders might decide, well, there's a bigger piece of equipment in there, different need, we need to stretch the room out. That's one thing that might change. Or we need to add 3 pieces of equipment or change out all the equipment for that matter. So that's one edit that happens in the criteria definition phase. So when that happens, you obviously have to update the templates. And if you have a lot of templates like this, having to manually manage them, it does take quite a while. The other edits that happen, we notice when a SEPS a project manager is actually defining a new project in SEPS and interviewing the healthcare, the stakeholders at a hospital, for example. The stakeholders might say, well, we see this eye exam room in SEPS, but we really need it to be 20 square foot larger, and we have these 3 specific pieces of equipment that we use in that room. So there's a manual editing process that happens in SEPS, which means that the output from SEPS, every room could be unique, even if it is the exact same standard as in SEPS. You can actually edit it manually. So that creates, again, infinite variations. The point being that with this much data, with this much movement, it's impossible to imagine managing this over time without a lot of effort and a lot of things missing, which is kind of what is the case today. The cycle of updating these templates and the criteria is very long because it is very labor intensive. This proof of concept is to isolate that challenge and figure out how to actually make that more efficient using the services-oriented approach in SEPS on max.gov. So the SEPS data, for example, the room codes and the associated attributes and the JSN and equipment information that is in that room, there could be quite a few pieces of equipment in there, and there is there are specific attributes associated with each equipment. So this pulse oximeter, for example, and we noticed actually this is the actual SEPS data, and we noticed that for some reason this pulse oximeter identifies that it has a medical gas in it. We've noticed this on a lot of objects in SEPS. We don't know if there's some, we're still evaluating it, but it looks like either there might be errors or the data was misinterpreted. So by exposing it like this, it actually makes it easier to understand what needs to be updated. That's another kind of a byproduct of making it web enabled. So for example, if we have a space and we don't have a template, let's say there's 0 template, but we only have a space that has equipment, and the equipment, it's actually nice in the MIL standard 6091 that the width, depth, and height of a piece of equipment is shown, which means we can actually create a block inside a space. In the SEPS to BIM export right now that currently exists that goes into Revit, this is already possible. You can actually export an Excel file, import it into Revit, create blocks in a space. The difference here in this proof of concept that we're showing is that this is also possible to do directly from max.gov and services-oriented approach. So for publishing information out, you can automatically create a template of a space. There won't be arranged, but they'll be stacked in the corner of a room, for example, with all the right pieces of equipment. Even if they're a low level of detail like this, they could still have the associated attributes, even of the equipment. So the equipment, the data associated with the objects is exactly the same, whether they're a block like this or whether they're a detailed object with the geometry actually defined. So for example, in this next view, here's a detailed object with the exact same data associated with it. There's no difference here. The only difference is that this creates a prettier rendering and it's good for presentation, etc. But the actual data and the reporting that would come out would be exactly the same. So over time, let's say this is a template for this adult exam room, 2012 version, but in 2014, the criteria gets updated and these three new objects are shown to be needed in the room. With this proof of concept, we can actually even take the detailed templates and populate them again, automatically populate them with new blocks directly through web services with the associated data, which means that this becomes a way to automatically or semi-automatically maintain templates over time, whether they're automatically generated or maintained with new pieces inside it. And then the end result is that the designers would actually have the right elements when they take it out into their design BIM tools of choice. So this is a view of these three objects again that were added into this existing template, going from say 2012 version to 2014 with the new data. And so these three models side by side, the data is exactly the same. It's just that over time, the one on the left could be automatically generated. The one on the right could have been manually created in BIM, arranging all the objects. The one in the middle is a new update that would happen when data gets updated in the criteria, or the designer decides to add three pieces of equipment. So those are the two options, that it gets updated in criteria, or in a specific project there's a need for three new pieces of equipment. We're still going back to the authoritative source of data in SEPS in the MIL Standard 1691. So we're all talking about the same data and not worrying about manually managing hundreds of thousands or even millions of pieces of data over time. So the end result of this is the data in SEPS becomes machine readable. Updating and managing data becomes more efficient. With this many templates and this many equipment, 808 rooms, this many room types are kept up to date at varying levels of detail. It doesn't all have to be at the high level of detail, but over time, that's the direction it will head to. So as more templates are populated with more detailed objects, then the templates become more accurate over time. So that the accuracy and timeliness of templates and criteria improves, and that's a big challenge in the current version of SEPS as well too. The timeliness and the time it takes to update criteria. With this proof of concept, it shows how we can radically change that level of effort and time and accuracy.